Hi everybody. Okay, so this is our last unit and it is on volume. All right, so I want you to take this square and it has a side 22. Find the area of the shaded region. So this is from geometry, algebra, middle school, whatever. So the area of a square is side squared. And then we're going to take away the area of the circle, pi r squared. So the side of the square is 22. And then you subtract off pi r squared. What's the radius of the circle? Well, if this whole thing is 22, then this is 11. So that's just 441 minus 121 pi. And we are done. Wait, is 22 squared 441? I think I did that wrong. Let's see. 22 times 22. That doesn't look right. 44044. 484. You know what? I did 21 squared. 484. All right. And that's area. So when we're finding the area of a shaded region, we take the outside and we subtract the inside. We're going to be using this idea to find the volume. All right. So this is what these problems look like. The volume of the region created when the square root is rotated about the x-axis. All right, so let's try to picture this. I'm going to apologize now. I don't think my picture is going to be very good, but I'm going to try my best. All right, I'm really good at these with chalk from when I taught before. So we have 0 to 4, and we have this shaded region. So imagine that that shaded region is being rotated around the x-axis, okay? So it's rotating, so it comes down this way, right? And it's rotating. So we have like, it looks kind of like a cup, like a funnel. Do you see it? Right? I'm going to show you some pictures. But that's the general figure. It's like, it's circular. So, to find the volume of something, what do you think we need to do? We'll define the area, right? When we did the integral of the function was the area, right? So what do you think we need to integrate? We're going to integrate the area of each circle. So, because if you notice, like the one on the edge, right? We have this is a circle. That's what we're going to integrate. So imagine we're like adding up the area of all those circles from 0 to 4. So from 0 to 4, we're adding up the area of the circle. Now, what is the area of a circle? Pi r squared. So we're going to throw a pi in there. And we need the radius squared. What is the radius of the circle? What is this distance? That's, see my blue circle? And we need the radius. What is that distance? That is your function. That's the square root of x. Dx. So let's simplify that. So we get pi. Okay, that's an ugly pi. 0 to 4. That's just x dx. So pi x squared over 2 from 0 to 4. So we get 16. So that's just 8 pi. And that's your answer. That is the area of that cup type thing. So here's a picture of what we just did. That's from 0 to 4. The other one we did was 0 to 4. This is 0 to 5. I grabbed this from the book. So hopefully this is a better picture. Sorry it's blurry. I copied and pasted it. But that's the idea behind what the picture should look like if you were confused by my picture. All right, so here is your definition. This is using discs, right? Discs are like circles, okay? Circles. That doesn't look like the word circles at all, does it? circles. All right, if a function f is continuous and non-negative on a closed interval, then the volume of the solid of revolution obtained by revolving the region about the graph of f, the x-axis, and the lines x equals a and x equals b about the x-axis is. So notice all this is pi. I like to think of this as r of x, right? It's the radius squared, right? We're integrating the radius over some interval. The radius squared, pi r squared. We're just finding the area. We're integrating the area of a circle. When you integrate area, we get volume. All right. Find the volume of the solid generated by revolving the region bounded by the graph y equals x cubed, the x-axis, and the lines x equals -1 and x equals 2. So let's look at this picture. All right, so I have x cubed, right? We have x equals -1 and x equals 2. So here is our little regions, and it's the x-axis. All right. So that black region is the thing that we're rotating. So when I draw this, what I kind of do is I draw like the reflection over the x-axis. So here it's going to do that. And then these are that's my circle. So it looks kind of like a cone. And then the same thing up here. It reflects up, and we have our little cone there, okay? So that is the region that we are finding. That's the volume we're finding. So again, we're focused on the integral of pi r squared. So pi, and they're giving me my ends, -1 and 2. Oops. -1 to 2. Something squared. What are we squaring? What is the radius of our circle? Well, the radius is just the function, right? So x cubed squared. So when I'm going to rewrite it. Pi -1 to 2 x to the 6th dx pi x to the 7th over 7 from -1 to 2. So that's pi. So the one pair of 2's cancel, so that's 64. Oh, I just lied. Just kidding. That is not a 2. That is a 7. X to the 7th over 7. X to the 7th is 128 over 7 minus pi -1 over 7. So we end up getting a plus here, right? Those cancel out. So we get 129 pi over 7, and that is our final answer. Okay, that's it. And then again, if you want to look in your textbook, I don't remember when you get the homework pages, you can see what the actual page was, but this is the idea behind the picture. So you have right, so this was the original function, right? That's ugly. And then the rotation, it makes this like a big cone and a little cone. So it's a little blurry. You can look in your book to see the actual picture of it. Okay, so now in those last two problems, the region was touching the x-axis. That's the most basic type. Now, what if the region does not touch the x-axis? What if it's just like kind of chilling out in the random open? So if I have, say, this region, so that function, right? So if this is my area and that's what gets rotated, it's not just a simple pi r squared anymore. It's like the do now. So it's pi big R squared minus little r squared, just like in our do now. Because imagine, So when I rotate this region around, right? I don't know if you can see that. When it gets rotated around the x-axis, it ends up having like this hole in the center because it's coming out, going in, coming out, going in. So we end up with our big R squared minus our little r squared, right? When we find that area. And I'm going to show you I actually have a video that I will show you on the computer tomorrow that you can physically see what's happening here. So just like the do now, it's the area of the big circle minus the area of the little circle. So I always think of it like this. All right, so pi big R minus little r. The outside radius minus the inside radius. And then here's another picture that I pulled from your textbook. So if you have your region here, right? That's the original region. And then as it rotates down, as we get over here, it's making this kind of weird cylinder type thing with a hole in the middle. And that's why we're using our big R squared, our little r squared. And it's talking about in the middle, we need this thickness, right? And think about the do now when we found the area. We did the outer area minus the inner area. And that's really the idea here. All right, so find the volume of the solid generated by revolving y equals 2 over x and the line y equals 3 minus x about the x-axis. So let's look at this region. So we've got, that's your 2 over x, and then 1, 2, 3. So this is our region, okay? So it's not actually touching the x-axis. So what this looks like, and again, the way I draw it is I kind of reflect it over, so it kind of looks like that. So there's my region down below. And then I'm going to draw in my circles. So notice there's this. So it's like, I don't know, this is a terrible drawing. I'm sorry, guys. So you can, if you can kind of visualize this, I'll try red. The part that's colored in is kind of, it's kind of like a piece of a cone with but it's hollowed out in the center. Okay. So see how it's got like this hole in the center? So that's basically what's happening. So we need to know where these things are equal, right? We need to know this point and this point. So let's find out where they're equal. So 2 over x equals 3 minus x. 2 equals 3x minus x squared. X squared minus 3x plus 2 equals 0. Factor. Okay, so these are equal. This is the point 1 and 2. So we know we're integrating from 1 to 2 pi. Now we need our big R. So our axis of revolution is the x-axis. So I'm going to put a point on the x-axis. What's the big R? What's the farthest away we're going? That's our big R. And then the little r is the closest piece. So big R and little r. What is big R? Big R is the part of the graph that's the farthest away. That's our line, right? That's the line, 3 minus x. So big R is 3 minus x squared minus little r. Little r is the curve. And again, I'm sorry, I have a better picture. There's a better picture of this. So minus little r 2 over x squared dx. So that is what we are integrating. All right, so let's simplify this. So you have a choice. You can multiply it all out, however you want to do it to simplify it so you can integrate by hand. So if I want to multiply the 3 minus x squared out, it's 9 minus 6x plus x squared minus 4 over x squared dx. We're going to find the antiderivative. So pi, don't forget the pi. That's like really important. 9 minus 6x squared over 2 plus x cubed over 3 plus 4 over x from 1 to 2. And the final answer, if you go through, is pi over 3. You can do that math on your own. It's really obnoxious. It took me an overly ridiculous amount of time to get the accurate answer, but it is pi over 3. All right, in the last picture, again, these are just so hard to visualize. I think that's what makes this, I was really scared to teach this the very first time. I really love teaching this now. I don't think it's very hard, but it's the visualization that makes it the most difficult. So we will, during our Google Meet tomorrow, I'll show you on my computer that software where we can actually see the visualization of it, and it's a lot better. All right, here's your homework. Here's a picture of somebody. Let's do Autumn again. So here's her ponytail. I'll give you ears. And there's your 5 that you're going to get on your AP exam. All right. Do your homework. Email me if you have questions. Have a great day, guys.